Hopefully you're here for retrofitting communities, the future of resilient homes. See a few more. We've got two very passionate, experienced, I'd like to say experts. I'm sure they wouldn't necessarily quantify themselves as that, but two great gentlemen are going to talk through their experiences and what they see in the retrofit market, building upon the theme of retrofitting the workforce. So hopefully, once we get through the presentation, they'll make some comments relating to labor and the needs, the demands in this industry, in this sector. But first of all, maybe just briefly, I'm Alex Joseph, and I'm the program manager of the Green Building Technology Network with the Smart, Sustainable, Resilient Infrastructure Association, or SRIA, and you can find us at sria.ca. We've really been working on 20 pilot green building projects across the province over the last 2.5 to 3 years, finishing up phase one, moving into hopefully a second phase over the next few years. So if you're involved or about to start some green building projects somewhere across the province, we'd be interested to talk and hear about those. Before I introduce Frank and Ben, what I want to do is just one slide to give context. And so if you're in the building industry, some of these things are probably much more front of center, things you're thinking about. If you're not in this sector, it's helped to kind of give some context. And so, of course, a lot of the presentations at this event and probably a lot of the things you've been involved with are around that 2050 national goal to reduce greenhouse gas emissions to net zero. And if you look at the Canadian context, buildings in general, depending on how you measure it, make up 25, 30, 40% of those overall national emissions. So the building sector is a significant part of the challenge and where a lot of the solutions are going to have to be deployed. Ultimately, to meet these goals, buildings have to get a lot better. And so in general, 70-80% of the buildings that are already in existence are the ones we're going to have to focus our attention. The new buildings increasingly are subject to higher and higher building energy codes, and they largely will move towards net zero as that market moves. But in terms of the existing buildings, that's where the solutions really need to be deployed. If we look at the residential sector across the country, we're talking about 10 to 11 million houses that need ultimately to be retrofitted. So the action and the challenge is a lot in the existing building stock. So with that, we've got two people today. So Frank Crawford, who's a PEng, civil engineer, and a certified passive house designer and tradesperson. So hands-on type of guy. 20 plus years in construction, 10 as an energy efficiency consultant. And his latest work has been around education committee lead with Passive House Alberta. So he's going to give you some context, a bit of his experience in terms of working in the industry and really trying to move that bar forward. And he's got a sort of an asterisk there, not an electric code expert, so maybe thinking about some of the questions in some of his slides. With him is Ben Hildebrandt, who's at SAIT. He's an architectural technologist with about 10 plus years focus on building science, and he's one of the principal investigators at SAIT's Green Building Technology Access Center, so involved in a number of different green building projects. He's a member of the Retrofit Canada Board of Directors who's working on pulling together case studies of deep energy retrofits. He's also working with the CHBA towards a net zero renovations on the advisory group, and he's had about 2 years participating in and leading research projects focused on residential deep energy retrofits. So with that, I think I'm going to turn it over to Ben.
Turn it over to me. All right. Thanks, Alex. So deep energy retrofits, so you see kind of like the involvement I've had in it. It's kind of interesting how young this industry is in Canada. in the understanding of it. A few of us at SAIT and our Green Building Technologies Research Group, we've had conversations, like my associate dean in the room here, about like 2-3 years ago, the term retrofit wasn't really out there, wasn't really talked about. It was being talked about more and more and more. So to really set the stage for our conversations today, let's talk about what is a deep energy retrofit. So something we do to an existing home or a building, and it's just taking a home, you want to standardly upgrade the siding or the windows, and we just go to the next level and significantly improve it. So we're improving the energy use of the home, often more than 50%. Preferably we hit like an 80% reduction in energy efficiency or energy use. And then that leads to the reduction in greenhouse gas emissions. And that's how we take these existing buildings and make them function a lot better when it comes to the building's share of our national emissions. So one of the things we want to look at too in a deep energy retrofit, which we'll get into a bit more, is that strategy and going deep and avoiding a shallow retrofit. So one of the things we look at now in the standard renovation of a home, the work we do now has a larger impact and a lasting impact. So of all the buildings that we're working on now, whether it's a new build or a renovation, the work we're doing to the building envelopes or that outer shell of the building, what's separating the inside environment from the outside environment, the work we do on the building envelopes will largely still have the same energy load in 2050 of the work that's happening now. So every building, every home that's being constructed across Canada this year, there's not going to be a need to really change it before 2050. So the work we're doing now, we're basically locking in those emissions. So deep energy retrofits are a big thing to look at doing, and I have a hard time staying on track and with the flow. I'm a real squirrely guy, things pop into my head, but I'll do my best as I go. And I might feel a bit raspy, I'm going to do a little side tangent to start. This morning, after getting the kids off to school, it was a 2.5 block sprint to the bus. I'm not in shape, and you know you're running fast when the bus driver compliments you on your running. So my throat is a little bit raw, so if I get a coughing fit, it's due to my unfitness, not an illness, so don't be afraid. So let's dive in here. What does a deep energy retrofit typically entail? We want to achieve drastic energy savings and thus emission savings on a building, but what does that mean? Largely, we're looking at improving the air tightness of the building. This is something that a lot of people don't really realize, is that there's a significant amount of energy loss from a home or a building just from air that leaks out uncontrolled through windows that aren't sealed very well or doors that aren't sealed well. And you know they don't seal well when you see light between the door and the door frame. That's a dead giveaway. My front door, you know the cobbler's children have the worst shoes? Yeah. Someday. We'll get into other influences that prevent us from doing a lot of this work. So improving the air tightness of the building, that's one of the lowest, or the low-hanging fruits of what we can do to improve the performance of our homes is air sealing. It's one of the cheapest measures that we can do. And then we look at, this is what everyone thinks about, is the upgrading or adding insulation to our homes to reduce our heat loss through conduction through the walls and attic and foundation. And we look at high performance windows and doors, and then along with that, we do all those initial improvements. We want to upgrade the mechanical systems and use more efficient mechanical systems, and that's where the whole conversation around heat pumps comes into the equation with retrofits as well. We get rid of a standard gas-fired furnace and switch to a heat pump with electrification, which we'll get into a bit more later on. And then after we do all that work, this is kind of order of operations and kind of what you want to look at roughly too and prioritize. Then after we do all that, we reduce our energy use. Then we look at adding renewable on-site energy generation. And then one of the targets we look at is net zero energy performance. So producing as much energy as we consume over a year on site on our homes. One of the key strategies and conversations that we'll be having today, which Frank's going to lead, he's done a lot of research around it, is that electrification or fuel switching, getting rid of any use of fossil fuels in our home and moving to all electric. as a strategy to reduce emissions. So this is all the work we're doing. It's a lot, and it's not cheap at all. It takes a lot of planning and a large budget, and there's different mechanisms to look at accounting for that. But why are we doing that? Is it just for the energy savings? Is it just for reducing emissions? There's a lot more benefits to it. So improve thermal comfort. How many when it was minus 35 were just hanging out in shorts and a t-shirt in your home right next to your big living room window? Anybody? Are you in a passive house? No. Not quite.
We did have it retrofitted level, but we also have a wood burning fireplace, so it's
Yeah.
really hot.
Yeah, you get some good radiant heat warming you up there. That's great. All right, so improve thermal comfort. That's one of the nicest things, and every time we go through a cold spell in the wintertime in my house, I'm like, gotta convince my wife that we can do this work, and the cost is worth it. Energy savings, reduced emissions, that's one of the largest overarching conversations we're having through this conference is reducing emissions, and how does energy contribute to that? And I think one of the things we look at with energy savings, if we can save the energy we need to run our buildings in the first place, then it doesn't matter as much where that energy is coming from. And when we look at that 50 to 80% energy savings in our home, if we can retrofit all these homes, if we can reduce the energy use from the residential sector by, let's say, 50%, then that's 50% less energy that needs to be produced, whether it's coming from natural gas or solar or wind. Another cool benefit, kind of associated, people don't use it as a target, is noise reduction in our homes as well. You have a highly insulated home that's airtight, you get a lot less noise transmission from outside. So if you have a home that's on a busy street, you're tired of hearing those cars go by, especially big truck at night, noise reduction is a good benefit of that. I think a couple of the other key benefits here towards the end of the list, extended life of the building. When we do a deep energy retrofit and we do it properly, you have minimal maintenance required on that building for 40 or 50 years. That's the target. So it's a lot of money up front, and sometimes you phase it over a few years to make it more palatable for your pocketbook. But when you do it right, your building setup, your home setup is going to work well for a while. Increased resale value, you get a great facelift update to your home. And then finally, resiliency. And this is a big one that's a larger and larger conversation over the past couple years as well. So when we talk about resiliency, it's making these buildings so they can withstand the increasing severity of environmental conditions and environmental weather events. So primarily, we look at the majority of climate events. We look at, I'm in Northeast Calgary, I got that ping pong ball sized hail back in 2020 at my house. Luckily, we're a stucco clad house, so we didn't get an instant reclad of our house without a choice. But there's resilience against adverse events like that, hailstorms, heavy storms, or heavy winds, winter blizzards. Some areas you have flooding. When we look at building resiliency into a deep energy retrofit, you look at what climate events you might be subject to and design to accommodate those. One of the key things we look at in Alberta, especially events a few weeks ago, is that resilience to cold weather. That super insulation and airtightness can help maintain that comfort through cold spells. And being able to do that through the envelope and upgrading the envelope, that's passive performance. It's something you do once and it just works, whether or not there is power. There is a passive house that was constructed in Calgary here just a couple years ago. Project Leo, if you Google it, there's a few videos explaining a bit more about the home. But that home has 2 suites with 4 adults in it. When the emergency alert came out saying, hey, reduce your energy use, they turned off their heat overnight for 10 hours with temperatures between minus 35, minus 33 in that range for 10 hours. Their temperature inside only dropped 2 degrees inside their home. So that's resilience. So it's not so much a concern of the renewables not being able to, we'll try not to get too political here, renewables not being able to produce when we need it, when there's peaks on the grid in the wintertime at night, when the sun's not shining, the wind's not blowing. But it's having that resilience that even if the power does go out, you have those issues, your family's still safe and warm in your home. So one of the key things I like bringing it back to every time we talk about retrofits or even new construction and improving efficiency is this quote from Emery Lovins: "The greenest unit of energy is the unit of energy that is never generated thanks to efficiency and conservation." So if we don't need it in the first place, the conversation of where it's coming from is less important. So there's a lot of work going on right now around Alberta and Canada and accelerating deep energy retrofits. There's a lot of funding programs coming from Natural Resources Canada. But here's a path, things we can look at to doing. So start with an energy audit and apply for the Greener Homes Grant amount. There was an announcement earlier this week. If you guys are considering getting into the Greener Homes program, so this can provide up to $5,000 in rebates for different efficiency upgrades to your home, new windows, new doors, added insulation, installing a heat pump. They do work at minus 35 if they're properly sized and installed. So up to $5,000 rebates that, even into solar. And then also through that program, you also have access to financing of up to $40,000 over 10 years interest-free. They announced earlier this week that program is being paused. So only at this point accepting applications up till the 19th of February, so that's just next week. So if you've been considering it, start that application. It takes 5 minutes, put it in. I did it 2 days ago. New windows coming this year, hopefully. The other thing we can look at doing is, sorry, lost my train of thought. So Greener Homes Grant and Loan Program helps us finance our retrofits. And then the other thing we need to do is look at getting additional help to help create that true net zero on-site energy and zero emissions plan for your home. I like how Peter Amarangan from Retrofit Canada puts this. He says, we need to determine what the ideal 2050 version of our home is. And it's not a question of, I've got this much money, I'm just going to do this now. But it's starting, and we made a plea back in the fall to Natural Resources Canada to kind of can we get some support through the Greener Homes or similar program to fund some time for an energy advisor to work with these homeowners and paint this picture. This is the best way this home can look in 2050. And then whatever we can do with the funds we have in our homes, whether it's just the windows now or attic insulation, replacing the furnace, whatever steps we take, it's all getting us towards that view at the end. We're all getting one step closer with whatever we do. At SAIT, we released a guide to deep energy retrofits last year. There's a website at the bottom. There will be a QR code at the end of the slideshow when we're doing questions, so you can link and download that. And I think one of the most important things, as I've mentioned, kind of is you don't have to do all the work on these retrofits at once. You just have to create that plan and make sure everything you do is working towards that plan. What's that saying? If you don't know where you're going, you're not going to get there. And that's one of the things we run into with homes as well in retrofitting and doing energy upgrades. Sometimes you might do one upgrade here, maybe through some federal funding in 2010 with some upgrade programs, and then 13 years later you go to do something else and you have to undo something that was done before because you didn't know what that larger picture was going to be. It all comes down to starting with a good plan. The other thing we can do with our deep energy retrofit is combine it with other aesthetic or space use improvements or upgrades. So things that might be motivating you to want to do some renovations on your home. Anyways, your siding's old, it's faded. Those darker vinyl sidings, they don't age very well in the sun. You need to update it. It's already 20, 25 years old. The windows are old and leaky. You want to do something, but how do you relate that to a deep energy retrofit? So here's an illustration that we have created. I believe it's in the retrofit guidebook as well. It's kind of relating, here's what we want to do and renovate our home already. We want to replace sidings, windows, heating system, different things like that. How does it relate to things we might do in a deep energy retrofit? And here's the benefits that we can get out of these steps beyond just the aesthetic upgrades. So there's a lot of things we can get out of these homes beyond just upgrading and making it look better and saving energy. And I think that's one of the things we need to keep in mind. So one of the things that Frank has been working a lot on, and I'm going to kind of introduce and set the stage, is building electrification. So in Alberta, this is a huge topic of conversation of moving away from reliance on natural gas or fossil fuels to power our homes and going onto all electricity to run our homes. So when we electrify a building, we're disconnecting that natural gas line and changing it so everything in our home runs off of electricity. So the main purpose behind that in Alberta is greenhouse gas emissions. Largely, it depends on specific homes, but largely in Alberta, it's, unless you do significant envelope improvements at the same time, if you just switch your natural gas furnace to a heat pump, it's not going to be a financial savings operationally in many cases. When we do electrification, we also will pair a solar PV or photovoltaic solar panels on your roof as part of the project. And that's where we really achieve greenhouse gas emissions. Because in Alberta, our grid is not all hydro-powered like some other provinces. We still have a lot of natural gas. So I like making this comparison here, we'll do on this slide quickly. So the graph showed now, the pie chart showed now is illustrating the electrical production capacity at the end of 22 in Alberta. This is if every source of electricity generation was producing as maximum power, this is how much energy we could produce instantaneously. So this is our capacity. We have natural gas, we have a 17% wind, 7% solar. I think I can see that from, it's a bit smaller on this monitor down here. But, so this is what we can produce if everything is going full capacity all at once. But those of us in Alberta heard about Alberta a couple weeks ago. At nighttime in the wintertime, we're not producing any solar, and when it's super, super cold, the wind doesn't necessarily blow as much. So 2022, at the end of the year, this is what we could produce. In 2022, for the year, this is what was produced and sent out to the grid, and this is where the sources are. So we kind of see there's a lot more natural gas actually being used to generate electricity. And it is something we are going to need. We're going to need to rely on for electricity in Alberta for many, many years to come. This isn't something we just turn off the taps and install a whole bunch of solar. So there's a strategy in adopting these things. And our grid is getting greener over time. So we used to be like the second worst province or territory in Canada, I think just 5 or 6 years ago, when it came to how dirty our grid was, how many grams of CO2 was emitted per kilowatt hour of electricity produced. But we are getting better. There's a good downward trend on that. But as we retrofit, we can reduce the energy use. We reduce the amount of our electricity we're using, regardless of what source it's coming from. We install solar. That makes it instantly green. That's where you achieve true emission savings when you do a retrofit, is through utilizing solar at the end as the cherry on top. But the obstacle to that is that's one of the higher price point items in doing a deep energy retrofit. So, and that order is really important, is that electrification in switching to a heat pump to heat your home from a natural gas furnace and removing all those other uses of natural gas in your home. That follows the envelope upgrades and other energy efficiency measures. And then we can have a nice, comfortable building, and we have a significantly lower peak load because of those steps we've taken early on. So we can go through, maybe not in a lot of homes, maybe might not be feasible to install the amount of insulation they have in Project Leo, so you're losing 2 degrees over 10 hours at minus 35. But still, you can be more comfortable for longer with less heat. And most importantly, the steps we take to improve the envelope and reduce the energy use of our homes during a retrofit will reduce our peak load on the grid when we do have those deep cold times, those peak loads at the winter time, in the depths of winter. So if we don't focus on improving the envelope, we'll still have significant peak loads in the wintertime. And when we have net zero solar, net zero is a real buzzword. Like, we can just add enough solar so our home produces as much energy as it consumes over the course of a year. But in the summertime, we're relying on other homes, other uses of that excess electricity in the summertime, we put that extra onto the grid. But in 2050, if every home's net zero, every building's net zero, and everyone's producing excess electricity in the summertime, where's it going to go? So when we focus on reducing our energy needs in our homes and buildings, we can reduce the significant summer excess supply, and we're also reducing our wintertime peaks where we still rely on the grid energy from other sources. So when we look at electrification, switching over and relying on electricity, one of the default routes is getting an electrical service upgrade. So changing your panel from being a 100 amp up to 150 or 200 amp panel to accommodate all these extra electrical loads you're adding. And this is me getting ahead of my slides again. But when we look at electrification, Frank's been studying a lot and working with other parties in the industry to compile a whole bunch of research on what does it take to do electrification without needing to upgrade our service, a 100 amp service. There's a lot of other impacts in that, which Frank will get into.
Perfect. Thank you, Ben. So when we're talking about avoiding that electrical service upgrade, there's a few reasons why I want to do it. The first one would just be personal cost savings, because the cost to upgrade from a 100 amp to a 200 amp service is somewhere in the $5,000 to $7,000 range, and that's the best case scenario if your transformer is near, your transformer has spare capacity, and you're able to actually make those wires bigger. If you don't, then it can quite quickly go up to over $20,000, and at that point, generally that electrification plan dies, and then some of those greenhouse gas savings also die with it. So we want to be able to design the house so we don't have to do this. The other side of that is the larger societal benefits. If one or two houses on a block go to 200 amps, the grid can probably accommodate that. But if we're all trying to go up to that larger system, then obviously you can't just double the system without doubling everything else. So all of our generation, all of our distribution, all of those wires we see running all over the buildings, all over Canada, all over the towns, are going to have to get twice as big as well, which obviously has a very large cost associated with that. We don't want to do that. The utilities would like us to do that because they get to charge us those fixed transmission fees to recoup the cost of doing that. So by us not upgrading all our services, we're going to keep those fixed transmission fees as low as possible, and they're already starting to go up. So for those two reasons, we want to try to avoid the electrical system upgrade. So how do we do this? There's a large report. There's going to be a QR code at the end, so I can't go through all the details. They're probably maybe a little too technical anyways, but you can go on a watt diet, use load share devices, use a smart electrical panel, split the electricity at the meter. I'll go to a few details. So a watt diet is basically just you're trying to calculate how much that peak load, how much the most electricity you're ever going to draw from the grid on the coldest day. You calculate that, and there's a specific way you calculate it in the code, but the watt diet helps you reduce that calculation by making a few different smart choices. One of those smart choices would be an appliance switch. So this is actually something you can do fairly simply, fairly cost effectively. If you guys are going to replace your laundry appliances, don't just get another dryer, don't just get another washer, get a combined all-in-one washer and condensing dryer. The nice thing is, this is one of the few times where everything combines, is since it's an all-in-one unit, it's been around in Europe for a long time, but now it's North America, you put your dirty laundry in, 2 to 3 hours later, you get clean, dry laundry out. So that's kind of nice. And since it's condensing technology, it doesn't need to have a vent to the outside, so it's 2 to 3 times more efficient at doing the laundry. And from an electrification point of view, you don't need that really big electrical circuit, the 30 amp 240 volt plug. You just use a very small 15 amp 120 volt plug. Talking next about the envelope. So Ben kind of talked about what a deep energy retrofit will look like on more theoretical. These are kind of some very vague targets that you're going to try to aim for. So get our air changes per hour. That's how much air is leaking in and out of the building, less than 0.1. If you have a 2x4 wall, add about 6 inches of insulation, about R24. If you have a 2x6 wall, then add 4 inches of insulation. Put in good high-performance triple pane windows. Insulate below grade if you can. At least 1 foot down to the footing is better. And if we have in that attic, stick a whole bunch of insulation up to add about our 80 of insulation into our attic. So that's kind of roughly what the deep energy retrofit is going to look like. And by doing that, we get our heat load down to about 8 kilowatts, which is probably going to fit on that electrical plug that we just freed up from our all-in-one washer dryer. So then we can start to electrify our heating system. We don't want to do that first very often because our load's too large. Once we've dropped the load, then we can electrify the heating and cooling system. It replaces our furnace, uses the same ductwork, and we use some type of heat pump, either an air source heat pump, which uses the exterior air, and in our climate, below minus 25, we'll still need some supplementary resistance electric heat as backup or fossil fuel backup. Or you can use a ground source heat pump, which uses the ground as the heat sink, and then it doesn't need that backup system because the ground never gets colder. We want to add an ERV, which is an energy recovery ventilator that will provide us that fresh ventilation into the building and also recover some of the moisture and the heat out of the outgoing air. And we want to reuse as much of the ductwork that we already have in the building. It's there, we might as well reuse it. But we still have a few other things we want to add. We probably want to add an EV charger, we probably want to add that big solar panel system, and we're going to have to add that supplementary electric resistance heater on our air source heat pump. So how do we do that? We use devices that are called load share devices. This is based on an appliance you stick onto your electrical panel board that allows you to add additional appliances to it, but doesn't actually change the calculation of your peak load. So it doesn't affect the peak draw from the grid. There's two main types. One's called a primary and secondary load share device, and one's called a circuit pauser. The primary secondary is good if we have two different appliances that have a similar large load, but work at different times of the day, because one has power when the other one doesn't have power. And the circuit pauser is what we should be using to add that large EV charger, because with the circuit pauser, it just controls or it monitors the mains, and if we're not drawing too much electricity overall, then it will give us power for that EV. So we can put a really big EV charger on without affecting our overall draw from the grid. And these things are pretty cost effective, $850 to kind of $1,300 for the equipment, 1 or 2 hours for an electrician to install it. You do need to use an electrician and you do need to take a permit out. The other thing you can go is one more step up. If you're wanting to add other things, you can use what's called a smart electrical panel. So this is, if you still can't quite make it under 100 amps, then you can use the smart electrical panel. Also, if you're wanting to have batteries or some type of backup generator, or maybe you have a duplex or a fourplex, a smart electrical panel might be a good option. They're good options because they allow connection of all these different pieces of electrical equipment. They do cost more. They're about $5,000 and more labor to install. But we still need to add that large solar PV system. So for these, what we do is we want to use what's called a splitter. And the splitter, it just basically takes your electricity coming from the meter and splits it to two different connections. One goes to your panel, one goes to the large solar PV system. So again, it's not impacting the electricity that flows through the electrical panel from the solar panel system. Because what your solar panel system can do, your solar PV can add more electricity, which will overload the bus bar. This is probably getting a bit too technical, so you can either read the report or read the slide or talk to me afterwards. But there is ways to, again, to avoid the electrical panel upgrade with a large solar PV system. All right, so now let's actually show you some people have actually done this to see that it can be done and it is possible. So here's a single family home built prior to 1970, pretty typical house, split level house. The roof was getting old, needed to be replaced. The siding was getting old, needed to be replaced. The windows were the single pane sliders, they couldn't open them in the winter. So a lot of things needed to be done anyways. So this was a great time to, instead of just doing like for like replacements, they did a full deep energy retrofit. So they dropped their energy use from 134 gigajoules down to 49 gigajoules. So about 80 gigajoules of energy savings on an energy model per year. They increased the architectural appearance of the home. They now have a nice 40-year warranty on their roof, easy to add solar panels to that roof. They have much more comfort because they've totally disconnected from the natural gas grid. They were able to recover some of the space in the chimney. They used to work at home in the very small little cramped office, but now they've kind of recovered the space from the chimney. They've moved their furnace into kind of a crawl space, so they've now made the space much more livable. They have a nice larger office for them. So it's not always just about energy, it's combining it with other comfort improvements and doing it when you have to do something anyways. And just not doing the like for like, doing the deep energy retrofit plan stages. Here they did it all in one stage.
All right, and I really like this project. So this is from EcoSynergy. It's a home up in Airdrie. And they really wanted to see kind of what can we do with a newer home to electrify or to do a, I believe they're branding this in some places as the no demo retrofit. So this is a 2010 home and started off with a 125 amp panel, 100 amp circuit breaker, standard building envelope for the time, 2x6 construction, a bit leaky, fossil fuel furnace, electric range vented attic. Basically, like, homes are still being built today. So in this, with the exception, a lot more homes are using heat recovery ventilators. So this home started off with 143 gigajoules of energy use, which is a significant amount. We can do a lot better than that, and that might be similar to some homes constructed in 1970. So energy efficiency across homes has not really improved much for decades. We are better than the early 1900s when we were insulating with newspaper or air and prayers. But this home is a really cool use case, and what can we do to electrify without over-insulating the home? So what we did, or what they did for this home is they used air sealing with aero barrier technology, where they're able to just mist through the unoccupied home before they moved in, and it goes in and searches out and seals all the cracks. They're able to improve the air tightness down to 1.2 air changes per hour, and I believe it was 3 or 4 to start air changes per hour in that home. And one of the biggest things they did was utilizing a ground source heat pump. So in this case, they didn't really reduce the energy it takes to heat or cool the home. They just changed where that energy was coming from. Rather than natural gas in the furnace in the basement, let's get the energy out of 350, 400 foot boreholes. So as you can see, there's an aerial shot of when they were putting in the boreholes in this home, and they're able to get that ground source heat pump system installed. It was pretty invasive. It's not feasible for every single home, but in the end, they're able to reduce their energy use from that initial amount of, what was it again? 143 down to 62 gigajoules on that home. So really good energy savings on that. They installed small solar system as well, utilize a circuit pauser for their EV to charge their Tesla Model S, use a condensing dryer, and they're able to cut the fossil fuel lines. So all this work they're able to do. The most invasive part of what they did, or invasive parts, was the yard impact of doing the ground source heat pump. They had 3 boreholes drilled down, and that's a full like oil well rig size drilling machine they had to bring in for that. There are smaller units which are coming out and becoming available to make it more feasible and accessible to install ground source heat pumps. And then they did this work before they moved into the home. So they're able to do that aero barrier treatment without much impact. Typically in an occupied home with aero barrier, you'd basically need asbestos or mold containment type done, because the aero barrier just mists into the air and lands on everything. So it's best done in an unoccupied home, and much cheaper that way as well. So they're able to bring their energy use down a moderate amount without too much steps, but then they really just changed that heat source to the ground source heat pump, which worked out very well. Total cost for all this work was $106,000. So not too bad, but it's a great case for them. 10 kilowatt PV array installed. A couple notes what they ran through is their loads went to 104, so they just were able to switch their breaker up to 125 amp ideally, but the local authority would not accept their load splitter, so they still had to upgrade to a 200 amp panel. So it's part of the authorities being aware of these key steps and being on board with processes and what really works for there. So lessons learned from the electrification work and deep energy retrofits as a whole, some of the projects that we've been tracking over the past few years. When it comes to electrification, you need to get your electrician on board. They're the ones that can do the load calculations and verify what can be done, what you can fit on your existing panel, and you also need to verify with your local authorities, your local municipality, to see what's required. And all the myths about how you can't electrify or it's going to be way too much, they're false. We can do it. Heat pumps work, even in cold snaps. They just need to be properly designed and installed. Electrification without a service upgrade is proven, and it is achievable. It's something we can do with minimal costs, and there's a lot of other benefits to them as well. But the biggest takeaway to take from all of this is to really start with a strong plan for deep energy retrofit. If you're thinking of improving your home, the best place to start is getting an EnerGuide evaluation of your home done that really shows you where your home's starting from. And then work with someone that's experienced, an experienced energy advisor. Hopefully he's the one they are the person that did that plan, and they can work with you to kind of figure out what the best version of your home is in a net zero state. And then that can paint a roadmap for you of what you need to do to move forward with deep energy retrofits and electrification. So that's the presentation. We're open for any questions you guys might have right now. And we have QR codes here if you want to connect with Frank or myself on LinkedIn, download the electrification report or our guide to deep energy retrofits.
Perfect. Thanks, Frank and Ben. Really started up high and really dove into the details. And I'm sure some of you homeowners, you're already trying to capture the whole series of details that came out there. And so some of the content that's available, and definitely, of course, come up and ask these folks some questions. But maybe unless there's a question immediately, and it looks like there's one. Why don't we do that, since we have about 15 minutes before lunch?
Yeah, let's start there. Oh, yeah. Oh, yeah.
In the
start with the mic, think with him.
Yeah.
Hi, thanks so much for that. Joining today from the City of Richmond Hill, this is particularly important to my current portfolio as we're trying to get residents to retrofit their homes. My question is pertaining to barriers and how you see a municipality playing a part in helping residents overcome those barriers and sort of what they are and what we can do to get our residents to retrofit their homes.
Yeah. Well, one of the best ways to get over the barrier would be to join the SEEP program. You're in Alberta? Sorry, which?
City of Richmond Hill, Ontario.
Ontario, okay. PACE program, which is a property assessed clean energy program. In Alberta, we had to rename it, so we called it SEEP, Clean Energy Improvement Fund. Basically, the cities will lend the homeowners money at a low interest rate using the city's borrowing ability, but they pay back on property taxes. So that's what we found is kind of the best way to give the financing to the homeowners so that they can then go do it, and then training the actual energy advisors how to do the deep energy retrofit, not just shallow ones, and training the contractors, again, how to do a deep energy retrofit, not shallow ones. So education that needs to be done. You could also be talking to your permitting department so that if they get just a like-for-like renovation to come in, to maybe say, no, if you're going to reside a building, especially larger buildings, let's put 4 or 6 inches of insulation up there because we're never going to have another chance to do it. So it's trying to find the good kind of, I forget they called it, the good times to talk to them when they're going to do something, to do something more.
Yeah, and I think to add a couple things to that, I think a lot of it is awareness for the general public as well really helps. That's one of the things we've been working on in Alberta, and how we can have sessions for homeowners to learn more. And part of that is how do we get, just speaking to the general public, is like how do we get people to attend sessions where we're providing information. Where are the touch points that we can provide? The financing is probably one of the biggest obstacles, but I think the most important thing, regardless of how the total cost is going to be covered, I think right now, and the place to start is how can we get funding so the proper plan is developed for these homes? There's a home up in Edmonton where they're doing a deep energy retrofit. I think it was one of the panelists done under this Sharia project. But when they went in to assess the home, it was very leaky. There's really bad leakage into the attic. And so what they pulled the insulation out in the attic, which was topped up in a 2010 government program. And so it's really, I think the biggest thing that we can provide to homeowners from municipalities or government is how can we get funding to make sure these people are going to start off with a proper plan for their home, not just go in and install a heat pump because they have to replace their furnace. Because that's the other hard thing to get around to is we want to do envelope improvements before we switch to a heat pump. But the vast majority of people are replacing their furnace when they don't have a choice. It needs to be replaced. It fails. And quite often a lot of these people in homes, the vast majority of Canadians, their furnace fails. They can't afford that furnace, that they need to replace it, whether a heat pump or whatever, let alone envelope upgrade. So that financial piece is the big struggle. But I think as long as we start a foundation of helping people know what the plan is for their home and to give some labor numbers as we look at how do we do these retrofits. At the CHBA meetings in the fall in Ottawa, Kevin Lee quoted some labor stats, and it's anticipated that in Canada, about 97,000 people are needed to staff the retrofit industry. Those of us in the group in Alberta that have been involved or talking to people doing retrofits, there's maybe at the most a dozen companies in Alberta, like really small, like 2-3 man outfits in Alberta, the majority of them doing retrofits. And we need way more. And so how do we scale that up? We're working on some national training programs through SAIT right now on Natural Resources Canada that we're collaborating to be rolled out and scale up. We don't have the skills in the country to do this work across the country correctly. So part of it is getting the plan right, and how do we scale up the workforce so the work can be done right. The type of work doing in retrofits, there's a large error margin. If things aren't done right, we can have really bad failures in these homes. Some of them not visible, but can have horrible health impacts with moisture and biological issues in the home with moisture in the walls. So my thing I look at is how can we get people to plan right, and how do we get the industry trained up to be able to do this work right. So, rant over, sorry.
Great presentation, guys. I'm really interested in this discussion around heat pumps. We split our time between Calgary and St. John, New Brunswick. And not only is the climate very different, temperature and humidity profiles, but the heating profile is very different. There, very, very few people are on natural gas. Some people have great big propane tanks. A lot of people have ugly heating oil tanks. There's a lot of that. Or baseboard heating throughout the entire home. A lot of people supplement their heat with wood stoves in the wintertime. So out there, there's a lot of conversation around heat pumps, and it's really picking up quickly. My question is around, with the installation of heat pumps, my understanding is that, and maybe it depends on what you're replacing, that you need to have a heat pump on every level of your house. Or if you already have a system for moving heat through the house, can you just have one heat pump, like replacing the gas furnace, as opposed to replacing baseboards, and maybe you do need to have one on every level?
Yeah, if you have a furnace and it somewhat adequately provides heat to everywhere in the space, just replace the furnace with what's called an air handler that runs off of a heat pump. Right now, a furnace is just an air handler that runs off a natural gas heat supply. So you just replace that with a different air handler but runs off of a heat pump. Or if you can't be able to do all the building upgrades right now, you might use what's called a hybrid system, which is a heat pump air handler with either propane or natural gas backup. So below minus 25 with current technology. They're getting close to minus 30 in the next gen technology, which is coming out. But below minus 25, there isn't enough heat for an air source heat pump outside to keep up. So you need some type of supplementary heat. So if you've done the envelope upgrades, electric resistance is good. If not, possibly propane, possibly natural gas is a good option now. Especially if your air conditioner dies and you have a furnace, don't put another air conditioner in. We should not sell any more air conditioners ever. We should just sell heat pumps. All a heat pump is an air conditioner that works in reverse. Air conditioner takes heat and rejects it outside and puts the cold inside. The heat pump in reverse just takes the heat from outside, sucks it out, and puts it inside. It's the same thing. It just works in reverse. So if you can't do the envelope upgrades first, the hybrid, maybe with natural gas or propane backup, is a good idea. But if you're not getting below minus 25 very often, which a lot of the coastal regions don't, then you can go straight to an air source heat pump because you're never going to go into that resistance heat. But we still always want to try to have some envelope upgrades. Again, start with a plan, but the application of the plan might be, I need a furnace now. And there are options to do that.
This on.
Yep.
Hi, I just have a quick question about the improved indoor air quality and the ERV ventilation. The reason I ask is because if all these new homes are being built to have improved air tightness, a lot of studies are coming out about new homes having high radon gas generation, especially around Calgary. I'm just wondering if you guys have done any considerations into, do these new houses get tested for radon gas, or is that what the point of the ERV ventilation is?
You want to?
Yeah, so with radon, and that's something that's through the national building codes and provincial codes adopting them, it's being addressed more and more. But the heat recovery ventilator, energy recovery ventilator, for those who may not know, that basically just passes the outgoing air, passes the incoming air, recovers all the heat from it. So this is something that runs 24/7 at a low rate of airflow, so you constantly have nice, fresh, clean air in your home. That does provide ventilation. Steve Norris is one of the guys who did a retrofit recently on his own home in town, and he's been kind of monitoring that ERV to radon and how that's impacting things. But with radon, the National Building Codes does set out processes to mitigate radon and properly ventilate below the slab. I don't think that an ERV and HRV is a solution to not have to worry about that. I think it's getting a radon expert. You have a comment on this one?
Yeah. Related to that though, if it isn't a post-2015 house, where you have a roughing underneath the house to deal with radon, are you seeing anything with the older retrofits where they don't have that ability underneath the building built in to help with radon mitigation? Are you seeing any spikes because you're dropping into, like your example, or 1.4 air exchanges an hour?
Yeah, so the radon enters the building generally from the ground going up through the cracks in the slab. So if we are improving the air tightness and trying to focus on the air tightness of below grade, we're going to reduce the amount of radon that will be able to get into our building. And then by having the ERV, which is a continuous mechanical ventilation, always providing us the fresh air above ground, which is not going to have radon in it. Any radon that might still seep in is probably going to be removed quicker and more completely. So that even if you don't have that radon mitigation, you should see a drop in your radon by the improved air tightness and the continuous ventilation. As an example, in my passive house, which I built 8 years ago, I did put sub-slab weeping tile, but I didn't do a full radon mitigation. But because of the air tightness, I'm 0.3 air changes per hour, and my HRV running all the time. My radon readings were 12 in the basement and 8 upstairs, which is very, very low. Other people in my neighborhood that just have a code minimum building were having 300, which I think above 100 is where you're supposed to deal with it. The other thing you can do when you're commissioning your ventilation system, and I'm a ventilation commissioning agent, is go a little bit positive. Normally you want balanced, which means the same amount of air is coming in that's going out. But if you're a little bit positive, which means you're bringing in more air than you're exhausting, then the cracks of the walls are going to make up the difference either way. So if you're a little bit air positive, you're pushing the air out of the cracks, which means you're pushing the radon out a little bit more, or the radon's got to work harder to get into your building. The radon just wants to get to air, fresh air, so it will take the easiest path. So if you're overpressurizing a little bit, like 5, maybe 10 CFMs, probably just 5 CFMs, overpressurizing your building, with all of these other things, you should be able to reduce your radon. I would still get it checked before and after, and if it still is high, then you might have to do the more active mitigation of depressurizing below your slab.
Yeah, and I would say one thing really quick too, when you're planning and preparing for deep energy retrofit or seeing what needs to be done for your home, I think it is important to get your existing radon conditions around your home assessed.
Yeah,
so you can
baselines.
plan appropriately, know how much of an issue it is, and develop a strategy. Some deep energy retrofits, you might be doing an invasive work into the mechanical room where you're changing things around, and it might be an opportunity to introduce some venting stacks below the slab to vent out the radon. But it's something that needs to be planned for and addressed appropriately. And indoor air quality as a whole, a lot of these, whether it's a retrofit or a new build, when we're making these airtight homes and introducing mechanical ventilation, there are a lot of studies out there about the overall health benefits from that. So it is something to keep in mind of other benefits we get from these retrofits beyond just the energy savings and emissions reductions.
Not sure where the microphone might have ended up, but was there another question? There, yeah.
I have a quick question. I was just wondering if, like in the electrification report, I was just wondering, like in these reports or guides, is there anything about like return on investment and life cycling of these products, just to get a better idea of, is it, how worth it is it? Like if you install solar, is it going to pay itself off in 5 years, 10 years, 20 years, 30 years? And do the panels only last 20 years?
Yeah,
things like that.
As far as payback, financial payback, solar is actually the best one, especially now if you're getting the $5,000 worth of greener home grants. Solar is probably a 10 to maybe 12 year payback, less, and that drops down at however many grants you add on to that. So solar is your fastest payback because you're buying panels that have a warranty for 25 years and should last for longer. So from pure payback, solar is your best investment. From a pure carbon savings, solar is actually your best investment as well. Most of the other deep energy retrofit improvements are going to have a pretty long payback. If you're doing those purely for financial, probably wouldn't do it. But what is the benefit to you to maybe your kids won't get asthma? Maybe if they have asthma, they might not have it as much. You're comfortable in your house. Like I live in the passive house. When it was minus 25 out, my kids were still sitting 2 inches from a 5-foot by 10-foot window. Like that's what performance is, comfort. When we sell high performance, or I sell high performance, I generally don't talk about the energy savings and the cost first. I talk about, do you want a comfortable house that's quiet? Great indoor air quality, comfortable all the time. You can go to every room. The basement isn't freezing in the winter. The second floor isn't roasting in the summer. Everything is comfort. What is that worth to you? So yes, if you're looking for financial payback, also, if I'm going to do a financial payback, I have to put down a fixed number that the mortgage rate isn't going to change for 25 years. Inflation isn't going to change for 25 years. What else? Like you have to fix all those numbers, and they've changed a lot in 2 years. So most of those financial predictions are a prediction and are going to be off. I know I'm going to be comfortable. I know I'm going to have less maintenance. I'm not going to have to fix things. I'm not going to have rot and mold and degradation of the building. So, yeah. If you're going to want to live in your house, that house for a long time, it's worthwhile. If you're going to sell quickly, maybe not. Or if you're going to sell quickly, use the SEEP, where the payback goes on to your property taxes and stays with the building.
Yeah, and I think just a really quick point on that, and some conversations we've had in Alberta right now, other locations, because of varying utility rates, it changes, but in Alberta, a deep energy retrofit is never going to be a purely financial decision. The equations just don't add up. And when you talked about life cycling and stuff like that, the mechanical components are going to have 15, 20-year lifespan depending on the components. But when you look at the insulation and the air sealing you're putting into the envelope of the home, if that's done right, that's 40, 50 plus years that you shouldn't have to worry about. And you're basically being left with a brand new home. And I think the other part financially to think about is if you're in an older home where You need to replace your siding anyways. You need to replace your windows anyways. You're just adding a bit more to get higher performance windows. Maybe your siding replacement would have been $40,000. If you add $10,000 to $15,000 to that to add insulation, you can significantly reduce your energy use. It's taking that whole picture into account, what costs you may have incurred anyways, which makes it a bit more palatable. And then I always like that other comparison people always make when you talk about high performance and what the payback is. It's like, well, what's the financial payback of your granite countertops? They're nice to have. You don't get a financial benefit out of it. And I have not heard of a single person that has gotten a net zero or passive house home and lived in it and hasn't said, oh, I don't want to live in another house again. So the quality of life in these homes, as I understand, I still got to sell my wife on it somehow, is second to none. The financial payback isn't there, but there are so many other benefits that go far beyond finances in taking these steps with our homes.
We gotta wrap it up.
Well, with that passionate pitch from both of these gentlemen, maybe join me in thanking Frank Crawford, again, his contact info with Passive House Alberta, and Ben Hildebrandt with State and the Green Building and Technology Center. Thank you. You enjoy the rest of the afternoon of the summit. Good job, Joe.
Good job, Frank.